Like many other theoretical physicists today, one is trying to find a description of the entire universe which unites two theories. There's Einstein's theory of relativity and gravitation, which describes the universe as a whole, galaxies and stars and even ourselves. And that works wonderfully. And then there's quantum mechanics, which at the moment only describes atomic systems, molecules and so forth, the very small. And that was discovered a little bit later in 1925, 10 years after Einstein's theory. And these two theories are very different, and everybody who has thought about this is convinced that quantum mechanics must be the more fundamental theory, must be the deeper theory, and in some senses it ought to apply to the whole universe. At least that's what most people think, and somehow Einstein's theory must be made to match that. Now, 40 years ago, people started really very seriously trying to combine these two theories. And one of the central problems they came up against is the way time is treated in the two theories. In Einstein's theory of relativity, time is extremely flexible. It seems to be there, but it's very hard to get your hands on it. On the other hand, the time that is used in quantum mechanics is just like the old-fashioned time of Isaac Newton, just sort of tick, tick, tick going on, completely independent of the whole world. And 32 years ago, at last an equation was found, which is called the Wheeler-DeWitt equation, and this is meant to be the equation which describes the whole universe, and lo and behold, there is no trace of time in it. It describes a world which is completely static. You cannot, time disappears from that equation. And there's been a lot of argument about can that be right and is it right and so forth. Now, I think it is. And I think the interesting thing is that you have these two theories, quantum mechanics and general relativity, with very different notions of time. And the only way, I think, in which you can unite them is by saying there is no time at all. Each has got their separate notion of time. So the only way you can marry the two is say there is no time at all. Physicists always have to have very simple models to try and explain the world. Suppose we had just a universe which was made of just only three particles, just three particles. Now, if that was the case, then they would always form some triangle. And this can be represented by this. This triangle could say there's one particle here, one atom there, and one atom there. And that would be like my snapshot of an instant of the universe, formed by those three particles. And then you see, there's another one. So, possible instants of time. Now, what I want to do is show you how you can put them together in a schematic way and represent all possible instants of time, and then I will truly show you what eternity looks like, because in a way eternity must be all of the instants of time that can be. These three axes are the sides of my triangle. So this axis is going to measure the length between particle 1 and particle 2. So this one along here going to be the distance between 2 and 3, and this is going to be the distance between particle 1 and 3. So I'm going to represent this triangle by a point with respect to these axes. And now I'm going to show you what the totality of all of them looks like. That's my land of nows, or Platonia as I call it. Now what is this here? Now this is an equilateral triangle. So the equilateral triangles all lie on the line that goes from this point down here and runs up the middle of the model out towards there. And this has a side of about this length, so this triangle is represented by a point about there. So here's another equilateral triangle which is a bit bigger, so that's a point a bit further out there. And these ones, this triangle is somewhere up here. Now, this is a model of, if you like, it's a model of all the states of the three-body universe. It comes to an end here at a point that I call alpha because it is so very special. And it has these frontiers, but in the other direction it opens out to infinity. These axes actually go all the way out to infinity. The point I'm trying to make with this is that it leads us to a completely different way of thinking about time. Now, the way people normally think about time is that it's like a line. It could either be a river, but a washing line is a very good thing. And this is the past, and this is the future. And each of the bits of washing there are the individual instants of time. And this is linear time. And the deepest notion almost everybody, including scientists, have of time is that it's like a river, like a line, like that. And now we can look at my alternative model, and you see this is a completely different structure. First of all, it's not linear. Remember, each point in here represents a now, a special configuration of the universe. So I can hook this here. This could be a history of the universe, because each point along here represents one of my snapshots, a now. So this could be, even if you like, the Big Bang down there, and this could be us somewhere up here now. The washing line, the image of time, goes on to infinity in that direction and infinity in that direction, from eternity to eternity. But this model, if you look at eternity in this way, then you see that in some senses a Big Bang is inevitable, because this point alpha is always bound to be there. And also it suggests why you can have a difference between a past and a future, because eternity is completely different at one end from the opposite end. It comes to an end here. This is the end of everything here that can exist. If the world is really timeless in the sense that I think it is and the Wheeler-DeWitt equation suggests, then there will be many instants. Each of them will be self-contained. Each of them will be like what we experience precisely now, but in very different ways.
The universe you're proposing, is that a universe in which all the things are juxtaposed in a kind of simultaneous situation? Is that?
Yes, quantum mechanics says that in a sense you have got to consider everything that could potentially exist. Everything that is logically possible has to be taken into account and actually influences everything else. The probabilities for everything are determined by everything. So not only is all of the past there at once, and all of what we think of the future in the old linear time notion, not only is that present, but countless other possibilities are also there in an absolutely unendingly vast space of possibilities, all there at once.
So, are you here or aren't you here?
This incarnation of me is certainly here, but also there is an incarnation of me in which I was never asked to come to Holland to make this film, and I'm just sitting at home in Oxfordshire having my tea.
Are you saying that the way we conceive the world psychologically is fundamentally different from the way the world is physically?
That seems to be very much the case. Quantum mechanics certainly suggests there is much more out there in the world than we conceive. And it may not be so impossible, because after all, before the Copernican revolution, nobody was in any doubt that the Earth is at rest. And in fact, it seems to be absolutely obvious that the Earth is at rest. I mean, how can we be sitting here in this studio? And nobody could believe that the Earth is whizzing round and going round the sun. And yet, in the end, the great scientists like Galileo and Newton persuaded us otherwise. And maybe this process is going on. And it took over 100 years for people really to accept Copernicus's proposal. Now, the quantum mechanics is much more remarkable, so I think it could take centuries in normal parlance for people to come to grips with it and really feel comfortable with it. Here you see all of my 2 days in Holland, really. This is my universe in Holland. Lots and lots of nows, and they're all different and self-contained. They're all snapshots, and it doesn't really matter in which order you put them. This is the first one I took at Schiphol when I arrived. Here I am getting my bags put in the taxi there. Here I've arrived at the hotel, and signing on. Here's the dinner party on the first evening with the producer and the researcher. And next morning, here we are going to Den Haag, to the home of Christian Huygens. And here's the camera team putting up doing all their work. Here's me preparing my...
How can you live nowadays without the concept of time?
Well, I don't get rid of the concept of time because it's there in my being. I have that experience of it, and in fact I'm a very punctual person, and my children are always teasing me because I'm looking at my watch and saying, yes, we must leave in 4.5 minutes and things like this. So that's all right with me, but what I also like to do is spend at least 4 or 5 hours of every day doing things where I'm just governed by the natural rhythms of hunger and the movement of the sun. I like to walk very much or listen to music, where I completely forget about the passage of time and just enjoy each present moment as they come, as they exist. There's only one way that this can end. I'm going to take a Polaroid of all the Polaroids, and that's going to be a snapshot of my universe in Holland.